In this video, we're going to take a second to look at the contract testing engine built within Tosca Cloud. Quick demonstration of this. When we have our standard interaction with an API, the API simulation is actually a two-part name. There's an API piece to it. There's also a simulation piece to it. Bring them together, API simulation. On the API side, whenever you're calling a service, you can build that as what we call a runnable test, which is a code level artifact that can be executed as a part of the CI process to validate the endpoint. And this is slightly different than regressive testing, where you're doing a full regression test on an API. In contract testing, it's consumer driven, which means the consumer is setting up a set of expectations that they have against an API so that they can communicate with it and get what they need. And all the consumers of that API can contribute to that contract or build their own contracts. And then every single time that a developer makes changes to their API, they simply run all those contracts to validate if they're going to break any connection with those services. There's a test double piece to that, which is why it's in simulation, because you can build your test against a mock service to validate that the calls that your client is making to the consumer are working against the mock that you have, and vice versa. Okay, how does this manifest in product? So in simulation, the agents that we have that are living all over the world can be deployed cross-platform. And so one thing that you could do is you could build one deployed onto a Docker container. And every single time that you check code into your code base, you could run these runnable services. Essentially a runnable service, this looks very similar to Postman or API scan here, but you build and design the type of request information and response information that you want coming back. You could validate them here inside of the platform, so you could kind of play with the service, or you could check them into source control and then run them every time your code checks in. Let me show you what that looks like. So here I have a folder that has a series of contracts that are associated with this particular set of APIs or with a specific application that I have that has these dependent APIs. I want to run these every single time my code checks in. And so in simulation, you can run the simulator and view the UI, or you can run the simulation just as a command line utility. So in this case, what I'm doing is I'm saying, every time the code's checked in, grab one of these Docker containers, do a git fetch, deploy my contracts to that container, and then run it and give me a report. And so that essentially would look like this. So my code checks in, it pulls out the necessary requirements, pulls down the contracts, and then starts executing them as code. And I've broken the environment so we could get some errors in the result. But essentially what you can see it doing is it's now going through headlessly and running each one of those contract tests. And if you have a verification, you see here it's getting some 200s. Okay, that's fine. And here's some 500s because, as I said, I broke the environment. Unfortunately, I can't fast forward in Slack, so we're just going to have to wait one more second for that last service to fire off. And we'll get a result, and that result is code. So we produce results as JUnit reports. So let me just do a word wrap here. And then they could use these results in their build pipeline to say whether the consumer is breaking contract with the producer. Love to talk to anybody more about this because I think it's very important. We do have a session coming up where Jeff and I are going to explore this a little bit deeper. Let me know what you think.